Hello, everyone. Welcome to our talk. I'm happy to present our findings on investigating the role of three different transactive systems in their ability to predict performance in software teams. So let me give you a quick overview of our theorized model and then our findings. First things first, we propose that collectively intelligent teams seamlessly adapt to changing task environment. What does that mean? As time goes on, the team encounters new types of knowledge interdependencies, higher levels or changing levels of workload, as well as different goal interdependencies. An intelligent team is able to sense those changes and then coordinate action to encounter that in order to maintain performance. Now, how does this coordinate? How does this team coordinate action? We propose three transactive systems work together, functionally speaking, to achieve this. The first one being transactive memory, which coordinates the skills of the members, which is if you are reliant on transactive memory system, you end up being a highly specialized team. The second one is transactive attention system, which tries to coordinate the availabilities of the different team members. And this is especially important in software teams because open source software teams, because people move in and out of teams very regularly. A well-developed transactive attention system is indicated by the level of heuristic signaling people use, as well as the amount of behavioral synchrony they achieve in their activities. And the final piece is the transactive reasoning system. This is the ability of the team to align the goals or fulfill the goals that or motivations that different team members might have. And again, this becomes very crucial in an open source setting because you have different types of software developers and you have to retain that they're ready to leave a project once they don't find any more value from a given project. As I've already been talking about open source systems, we specifically analyzed 509 project teams. The data, all our independent variables were available through the publicly available activity streams on GitHub, where these NPM packages have their code base as well as all their interactions, while the dependent variable of about the quality and maintenance of these packages was reported by the official NPM website. We theorize that all three of these functions, through using their indicator behaviors, will predict performance, and we expect task overload and knowledge interdependence to moderate these behaviors. For our results, very quickly, what we found out that while we saw different developers specializing across their tasks, we did not see that specialization actually predicted performance. This was neither moderated by the level of interdependence exhibited within a project. For transactive attention system, we found both the indicator behaviors of signaling and synchrony predicted performance, as well as these were more important or these become more important at very high levels of workload. And finally, for the transactive reasoning system, we also found support and evidence for a well-developed transactive reasoning system that is high commitment and high engagement predicts performance. And this is more important when the knowledge interdependence is very high within the project. And just to make this point very clear, that the moderation for the especially for the transactive attention system only happens at very high levels of workload. So we don't see it seems to us that it might be a nonlinear effect. So these are some very exciting results, and we are really looking forward to investigating more in future studies. Very happy to take more questions. I'm Pranav. You can reach out to me through my email. Thank you.